This video is to show the use of machine learning approach in the optics application, especially in the photonic crystal fiber. So here in this video I'll show you about the code and the graphs which I have obtained through it, and I'll quickly show you about the graphical user interface also, which I have developed. So it becomes very easy to obtain outputs with the graphical user interface. You just change the values and you instantly obtain the outputs. So the PCF fiber or photonic crystal fiber which we are using, which will be something like this, a hexagonal PCF with the solid core. And basically in this I'm trying to compute the effective index, effective mode area, dispersion, and the confinement loss. And the machine learning, the ANN, the artificial neural network from the machine learning will it is of this general form. But for our design, our application, we have used a 3-layer structure with a 3-layer hidden structure with the 50 nodes in each. We have 5 inputs and we will be concentrating on 4 outputs simultaneously: effective index, effective mode area, dispersion, confinement loss. These are the outputs. Inputs are, you can change the refractive index of core, wavelength you can vary the diameter of the holes, air holes, the pitch and number of rings. Okay, so the graphs which are over here for the effective indices at showing these patterns, showing the predictions, these all I have obtained from the code, which I'll just show you in a minute in fact. So yeah, these are the graphs. Okay, so let's quickly show you the code. Okay, I won't go into the detail of the code because it will be a big task. So this is a big code. So here in the code, I'm just taking the inputs through the files. Here is the artificial neural network which I was showing you over here. Let me go to the slide. So this one with the 3 layers with 50 nodes each. So where is that code? Yeah, so these are the 50 nodes each with a 3-layer system, and followed by the whole machine learning approach, forward and back propagation, correcting the errors, calculating the mean squared error, and so on, then predicting the values and so on, and then plotting some graphs. So these lines over here, they will be mostly about the graphs, so I won't go into much detail. The code is available on my GitHub website, which is over here. So if you click on over here, so it will take you to the code. If you are interested to see the code is all over here. If you go in this Python file, so code is all given over here. Okay, so let's go back to the code, and these are all the plotting libraries, and then here at the end I'm making the GUI. Okay, let's I'm not showing the code, I'm just telling you how like overview. So let's just run it quickly. Okay, so when I'm running it, so okay, it will start it is reading it, and you can see that as the iterations are increasing, 100, 200, 300, I have ran it up to, I guess, 5,000 iterations. So this is showing the mean squared error continuously. Mean squared error, this MSC loss is the mean squared error for the training set. MSC loss validation is the mean squared error for the validation set. We normally make validation set out of the whole big set of the data, the input data. So both should be decreasing, and of course they decrease. This is the funda of the machine learning, and when they reach to a lower value where it becomes stable, also we kind of stop over there. And so this epochs is generally finalized by the user. So over here in the presentation I have taken different epochs, the graphs, 1000, 2500, 5000. So same thing is happening over here. So epochs is increasing. So let's just wait for a few seconds, and soon it will complete till 5000 epochs, and then it will stop, because this is how I have coded it. Okay, so actually I just wanted to show you the graphical user interface quickly, like how I have used it to quickly predict the values. So yep, it's nearby, just few more seconds and then it will stop. And first it will show the graphs because I have kept the graphs open, and then I'll close the graphs and the GUI will pops up. So see, you can see the various graphs are showing over here. So these are all the graphs for the confinement loss, but don't just compare these graphs with the one on the website or with one on my paper, because I might have taken different inputs or different outputs. So but the graph will be plotted like this. So once I closed it, so now the GUI pops up. So here we have the material, core, holes. You can change the material depending upon the code. You need to feed in few more inputs. So if I change the default value of the wavelength is 1550 nanometer. If I change the value, let us suppose I want to see the N effective area, dispersion, and the confinement loss at this particular wavelength, and where the number of rings are 4, and let us say I don't want the pitch 1.5, I want 1.1, and I want diameter by pitch like this. I just click over here on the calculate and it will show the value, okay, instantly. And let us suppose I want to change the pitch now to something else. I again click over here, calculate, the values will be changed, and I click over here, the values will be changed. So this is the GUI which I have made, okay, to show the values. So just to make things easy for me, and yeah, and after that I have plotted all of the graphs out of it, so which were here, then which was got published in a paper, and yep, that's it. Okay, so that's it for now. Thank you very much. I'll close it now.